Hello everyone. In this video, we are studying about mixed grouping, where your there will be a certain number of cells that are connected in series, and they will be connected in, and more number of cells will be connected in parallel. Okay. So first, let me draw number of cells. Okay. Let me draw the circuit. So here we'll be taking n number of cells. Okay. Right. And n number of cells in one wire, you can say. Okay. And each having internal resistance small r and EMF E. Right. And there are m rows. Okay. Means circuit will somewhat look like this. Okay. E R and so on. Okay. Again it will be like this. Okay. Up to m number of rows. Okay. And so on. Okay. And uh, this is connected to your external resistance capital R. One thing you need to remember that each cell in the circuit having internal resistance small r and EMF E. Okay. Now total number of cells will be कितने होंगे हो जाएंगे ये सी एक सर्किट में एक वायर में n नंबर ऑफ सेल्स हैं और टोटल नंबर ऑफ रोज कितनी है m तो टोटल नंबर ऑफ सेल्स क्या हो जाएंगे n इंटू m राइट नाउ ऑन रिड्यूसिंग दिस सर्किट सर्किट कुछ इस तरीके से दिखेगा अगर आप देखो तो अब चूंकि सभी क्या है सेम पोलैरिटी में जुड़े हुए हैं मतलब इसका पॉजिटिव इसका नेगेटिव इसका पॉजिटिव इसका नेगेटिव क्या हो जाएंगे सारे ईएमएफ क्या हो जाएंगे ऐड हो जाएंगे राइट मतलब सर्किट कुछ इस तरीके से दिखेगी ओके अप टू एम रोज ये क्या है एम रोज है और एक का ईएमएफ हो जाएगा एन इंटू कैपिटल ई और इस रेजिस्टेंस हो जाएगा इंटरनल रेजिस्टेंस एन इंटू स्मॉल आर ये क्या है रिड्यूसिंग रिड्यूस करने के बाद ठीक है नाउ इफ यू लुक दैट नाउ इंटरनल रेजिस्टेंस विल बी फॉर दिस वन see they all are in parallel so their resistance will be you can say 1 upon r equivalent equals to 1 upon nr plus 1 upon nr plus and so on up to m times so this will be from here you will get r equivalent equals to nr upon m right e equivalent you can get e equivalent will be r equivalent into given by r1 plus and so on from here you can write r equivalent is nr upon m and e upon nr plus ne upon nr plus and so on see even e2 is and so on they have see the resistance of this is ne and again for this circuit it is ne up to m times okay पिछला वीडियो देखेंगे तो समझ में आ जाएगा ये कैसे लिखना है ठीक है तो यहाँ से आपको क्या मिलेगा ई इक्विवेलेंट जो होगा ये हो जाएगा आपका सी यहाँ से एन एन कट जाएगा एन एन कट जाएगा ये क्या हो जाएगा एन आर बाई एम इंटू एम टाइम्स है ये हो जाएगा एम एम कट जाएगा ठीक है और यहाँ से आर आर कट जाएगा तो ये आ जाएगा एन इंटू मीन्स इक्विवेलेंट potential or you can say equivalent EMF it will be n into E so current will be M N E upon NR plus M to capital R, right? From the previous video you can see how we have got this formula. Okay, now what will be the condition for maximum current in mixed grouping? For I to be max, what should be there? This should be minimum. Now you can put Z equals to NR plus M into capital R and Mn equals to K, since this is a product of two numbers. So you can get substitute this M as you will get Z is equal to NR plus K into R by N, right? Then differentiating it with N dz by dN, you will get R plus KR, sorry, R plus KR into minus 1 by N square, right? And for minimum dz by dN, it should be 0. Okay, so R plus K into R minus 1 by N square is equals to 0. From here you will get small r is equals to capital K into capital R upon N square. From here you will get, you can put the value of K as M into N, so you will get capital R is equals to N into R upon M. This is why, this is what, this is the condition when I will be max. So you can also find out maximum current. You just need to put the value of capital R in this equation, you will get it. Okay, and I max, it will be M into E upon 2R, or you can say N into E upon 2 capital R. This will be your maximum current. Okay, that will be flowing through this circuit. Okay, so this was how you will find the maximum current in mixed grouping, right? Now we'll practice one problem. Okay, few problems on this topic. Okay, and then we'll move up to measuring devices. Okay, thank you.